what's called the conservative margin of error. This comes from chapter 5, the first one in chapter 5, which I can't remember the name of it. But in chapter 5, the first one, right at the end, there's a couple of questions that talk about this, right? So that's where it comes. The rest of chapter 5 we've covered. Wasn't it listening to me talk a lot in terms and different kinds of bias and different kinds of samples? Almost all of those questions, aren't they? Here's a story, pick one of the 4 that describes what's going on. So as far as your homework goes, it's just a matter of picking the right question. You know, the right answer to, I should say, the question. So we are going to look at 3 things. I've got them here. Conservative margin of error, which is a percentage, obviously. And this is the formula for getting it. We'll talk about what that is. Oh, I should have waited just a few moments more there. Somebody just turned up. Then, oh, maybe I should have waited even more because there's 2 more people turning up. Do you think they're trying to avoid my jokes? Okay. We're going into the details, but here is how you find the conservative margin of error. It's this formula. You then have to move on to how do you find what is called a 95% confidence interval, and this is the formula. And then you get a question that says how big does a sample need to be? And I haven't written the formula for that. So the size of the sample n is 1 over the conservative margin of error squared. But when you use this 3rd formula, the conservative margin of error is a decimal. In other words, you use the decimal version of it. Okay, now I've got the kind of the heading of it. Let's tell you how this thing works. Let's suppose, note to myself, send out an email. Let's suppose that we asked 1,200 adults, right? A nice random sample of 1,200 adults. And we went and asked them, have you ever been to Scotland? And the reason we're asking this question is that we like to find out, or try and estimate at least, what percentage of all adult Americans have been to Scotland, right? That's typically why you do samples, right? You ask a small representative group, and then you make the inference that if you do a good job at that, whatever answer you get, that's roughly going to be the same percentage of Americans who would be the same thing. So there's a guy called the conservative margin of error, and that would be question A. It would say something like, find the conservative margin of error, right? It would just say it right out. And it is 1 over the square root of n times 100, and your answer is a percentage. So you go to your calculator, and you do, where is it? 1 divided by the square root of 1,200. Multiply that by 100, and the answer I get is 2. If I round it off to say 1 decimal place, the answer is 2.9%. If you ever listen to the television, especially when it gets near to election time, but even before then, aren't there all lots of polls going on if you watch Fox News and MSNBC and all the other ones? And they say like, President Biden's favorability rating is this percentage. And then they say the margin of error is 2% or 2.9%. You ever heard the margin of error phrase? Listen to it next time. And they don't always tell you that, but they should. They should tell you this. Now, what this number is indication of is how accurate your estimate is going to be. See, if I went and said to you, I conducted a survey and 20% of Scottish people in my sample said they'd been to Scotland, you'd say, okay, 20%, 1 in 5 Americans have been to Scotland. But I really don't know whether that's a very accurate estimate or a horrible estimate. I mean, I could have asked 10 people, couldn't I? Which case, you know, how reliable is that? I could have asked 20,000 people. So the margin of error is an indication of roughly how accurate it is. You want this number, or at least you hope it to be, very small. Because if it's very small, it means that your answer is good, right? So back to this story of asking the adults in my sample. Let's say that the percentage from my sample who said they'd been to Scotland, so the percentage who said yes, to make it straightforward, was 23%. That's fine. Question B would ask us to find what is called a 95% confidence interval. We tend to call it 95% C dot I for short. And it's the percentage who said yes. So you ask some people a question and whatever it was, 40% said, I'm going to vote for that guy. 22% says I'm in favor of this. In this case, 23% said I've been to Scotland, right? That's the number that goes here. And then it's plus or minus the conservative margin of error. So our 95% confidence interval is 23%, give or take 2.9%. So if you're listening to the news, they might say, oh, there was a new poll, a new survey conducted, and 23% of Americans have been to Scotland with a margin of error of plus or minus 2.9%. Hi, Brianna, is that little one yours? Right.
Yeah, he's stealing my big giant unicorn stuffed animal in the corner.
So this 23 plus or minus 2.9%, 23 take away 2.9 is 20.1%. And if you add it, you get 25.9%. Do you get a better feel now for how accurate my prediction is based on this sample? We would say that we are 95% sure the percentage of all Americans who've been to Scotland is somewhere roughly be what, 20 to 26%, if you look at this. Now, it's a funny term, 95% confidence interval. You'd think, why don't they just call it a confidence interval? Or for that matter, why don't you just call it an interval? It's not just superficial. That number is actually telling us something. We are only 95% sure that this interval contains the real answer, right? The real percentage of Americans who've been to Scotland. If you look at that in another way, doesn't that mean there's a 5% chance that we were just wrong? This interval doesn't have the right answer. The real answer is miles away. And in statistics, that is what happens. We aren't ever, and if anybody says they are, they're lying to you or they don't understand statistics. We never say we're 100% sure of anything. I mean, in real life, couldn't I do another sample? In fact, if I did another sample of 1,200, would you expect every single time I get 23%? If I asked 2,300 or 1,200 different people, would you agree it would change a little bit every time? You'd expect that, just normal variation. So you can't be sure. Couldn't I just be really unlucky and got a lot of people who've been to Scotland? Might my sample had maybe more than is typical. And in that case, couldn't this interval be wrong because of that? So the 95% confidence interval means that whatever interval you've collected, you're only 95% sure that the real answer is somewhere in that range. Right? Not a guarantee, but 95% is pretty good. You don't know this answer, but you might be able to guess. Do you know there's 3 typical confidence intervals? This is the only one you're going to deal with. Later on, you'll see the other 2. What percentages do you think they might be? So this is a 95% confidence interval. What kind of numbers do you think the other 2 confidence intervals might be?
80%.
You might have said it, Eric. I didn't catch it, that's all. What did you say?
80%.
Oh, a little bit higher, but nice and round.
85.
No, that's not round.
95.
90%. So 90% confidence interval, 95%, and the last one is 99%. If you created a 99% confidence interval, wouldn't you feel really good that almost all the time you've got it, right? You know what the right answer is, give or take. You know it's in this interval somewhere, right? But there is no such thing as a 100% confidence interval, right? So don't believe anybody who says that they have done statistics and that is true, because it never is. Now, the third question is, how big does a sample need to be? This particular sample generated 2.9% margin of error, right? Let's suppose I want to do a survey and I want this margin of error to be, I don't know, 0.5%, right? So when I'm finished, whatever it is, plus or minus 0.5%, would you agree that's going to be a really tight interval? I should be really comfortable about my answer being accurate, right? But how many people do you need to ask to get that confidence interval? You see, it's kind of not so obvious. Well, the good news is there's a formula for it. The number of people that you need to ask is 1 over the conservative margin of error squared. But make sure that the conservative margin of error is a decimal. That guy is a percentage. The conservative margin of error that we are going to use is what that guy looks like as he is a decimal. How do you get 0.5% and convert it into its decimal or proportion version?
Move the decimal to the left 2 places.
Correct, or divide by 100 is also correct. Now, this is what calculators are for. 1 divided by 0.005 squared, and we are looking at, good grief, 40,000 people. And it doesn't matter what the question is. You could be asking them, have they been to Scotland? Are you going to vote for a Republican? Are you going to vote for a Democrat governor? Are you going to vote at all, right? Do you like beer? Right? It don't matter what the question is. If you want to get a margin of error, right? If you want to do one of these confidence intervals and you want a margin of error that's within 0.5%, you will need to ask at least 40,000 people. Can you see why that is very rarely done? Can you imagine how much money it costs to do a sample, a good, sample with all the things that we talked about in the last few days being taken care of, right? A nice, simple, random sample. It would, yeah, I could see it costing you $1 million. Not far off it. So Bill Gates is the only guy who's going to pay that money, right? But at least we now have a way of finding it out, right? Any margin of error that you want. Somebody give me another margin of error. A bigger one than that, just so we can do this calculation again. Pick any number bigger than, 0.5%.
1.5.
1.5%. Now, what you can do if you want to be sneaky is the next time you're watching the TV or listen to a radio show and they tell you one of these 42% are going to do this and the margin of error is 1.5%, right? For example, you can do this calculation and you can figure out how many people they asked. How many people do you think they asked to get this margin of error? Hundreds or thousands?
Thousands.
I think it would probably be thousands. Now, as a decimal, are we okay with that guy being 0.015? Are we comfortable where that came from? So the number of people that would have to be in a sample with this kind of margin of error is 1 over 0.015 squared. And my gut feeling was thousands, but I've been proved wrong before. But not this time. And now, I'm listening to the TV and 20%, not 20%, that's too big. They tell me something and they tell me that the margin of error is plus or minus 6%. Now that's not totally unreasonable. I've seen margins of errors that are, well, at least 5%, at least I've definitely heard of those. How many people do you think you need to get a margin of error of 6%? Hundreds or thousands?
Hundreds.
Let's sign up. Well, I guess round it off, 278 people. If you were only asking 278 Americans anything, should you even really pay much attention to whatever the answer is? Because I wouldn't. Can you get all sorts of weird answers if you just, by bad luck, right? So be really careful when you hear information about surveys, they tend to call them polls, on TV or radio, especially ones that are concerned with politics or something that's important, right? Like that. Pay careful attention to what the margin of error is. Because if it's anywhere close to 6, 5%, something like that, I tend to pay no attention to them, because it almost always means the sample was tiny. And I think, simple sample, small samples, anything. If you did a small sample, couldn't you get a large percentage of people who think my jokes are funny? I mean, it could harm, right? So pay attention to the details. Isn't the devil in the details? A lot of people just say, oh, 47% think this. But if it's 47% and the margin of error is 8%, do you know they probably only asked 100 people, right? Not a good sample. I don't pay attention to it. Now, if the margin of error is 1%, yeah, well, they must have asked at least thousands. Now I'm paying attention, right? Provided they ask the question right and all the other stuff that comes after that. Are we comfortable about this margin of error, conservative margin of error, give it its proper title, confidence intervals, and how big samples should be? Feel good about that? You don't get much. I think you get 2 questions and that's it. Oh, little thing someone brought up in my other class. One of those 2 questions that you get asks for the conservative margin of error as a proportion. Which one of these 2 numbers then do you write down if they say as a proportion? Because the other one says as a percentage.
The decimal.
The decimal one. When you see the word proportion, I want you to remember that it just means decimal or fraction, right? A half counts as a proportion as well, right? Decimal or fraction. And it's easier when they say percent, isn't it? Because it's obvious a percent, right? If there aren't any questions about that, let's talk about the test. Are we good? So I'm going to, oh, and in the chat I should know about it. Okay. Let's kick over to screen 2. What you will notice is that we now have an extra module called Test 1 Information. So no particular order, let's start with this one. When you turn up on Wednesday, because that's the day that your test is going to be, oops. What am I putting Tuesday there for? Oh, sorry, your test is on Wednesday. Oh, wait a minute, I may be in the wrong class. Let me check that. Problem with having 2 stats classes, at least for my brain, is that you can't remember which one is which. Okay, let's fix that. Okay,
It's the 13th, not the 12th. That
Correct.
meeting.
there we go. Now, updated. Do you now see the right heading? Okay, you are not going to use your normal Zoom link. You're going to use test 1 Zoom link, right? So it's going to be a different Zoom link from usual. Test 1 Zoom link. And that will get you into class just like we're doing right now. And since it's a test, the rules are a little bit more severe, but it's to be fair and to stop cheating. I need to see everyone. So I need to see Abra as I can to make sure her twin sister isn't beside her, writing down her answers for her or pointing at things for her, right? That's obvious. We need to see you. Now, I don't always get everybody's picture, so that causes a little bit of issue. If you do not have a video yet, then you've got a little bit of time, contact the college. You might be able to get one. Use your phone as a good backup. You know, you can go to Zoom, download the app and have Zoom and connect that way. And I can see you through your phone camera. I just need to see you, right? Whatever way that works. Your test will start at 1 o'clock and it will finish at whatever, 1:30, probably. I'll round it off, nice round number. Won't need that amount of time. You should need about an hour. So the other 30 minutes is kind of wiggle room in case you take a bit longer. The test, when you do it, will be on WebAssign, just like your homework. It's not there right now because it won't be there until it's time. But when it is there, it will just say test 1. Also, when you turn up on Wednesday, everything else that you've done in WebAssign will have disappeared for a day. So the only thing you'll see in WebAssign is the test, right? So you won't be able to say, I don't know where it is. It's the only thing there. And it will be just like homework, right? It's WebAssign, right? So you get questions where you pick a circle for the right answer. There's questions where you hit the salt button, right? There's questions where you type in 42% and all the usual things. It'll just be like homework. In fact, that's essentially where I'm getting the questions from. I just go into WebAssign's homework library and I pick questions. Now, there's a little bit of difference here than normal. Normally, don't you do all your homework and you just write the answers into WebAssign? And sometimes you need working. You know, that last question we did, the margin of error, wouldn't there be some writing, some square roots, some hitting buttons in calculators and a whole load of other stuff, just to get the 2.1%? Well, normally in usual homework, I don't see that, right? But in the test, I want to see that, which means there are going to be a couple, 3, 4 questions in your test where I can see some working. So I'll give you an example of situations where I would expect to see working. If I gave you one of those margin of error questions, would you say it would be reasonable that there'd be some working associated with that? If I went and asked you to check if 98 was an outlier, don't we have a test involving the interquartile range? And we also have another test involving standard deviation. Isn't there working associated with that, right? If you got a question that said, what percentage of people didn't like carrots? wouldn't it be a little bit of a percentage question where you'd say 14 out of 42 times 100, 17.9%? In WebAssign, you might only put in the 17.9, but wouldn't you be able to show me the working for it? Right. If you're not sure what questions need working, just say to me, I'm doing question 3 right now. What kind of working are you expecting? Because a lot of questions I will not be expecting working from. Do you know the ones where you hit the salt button and everything's in salt? I'm not going to say working. Do you know those questions where they tell you a story and there's 5 choices and you pick what kind of sample it is? I'm not going to see working for that kind of question, right? So there are a lot of questions where there isn't any expectation to see working, so I won't be looking for it. But there will be some where I do expect to see working, right? So for instance, if you have to hit the button on your calculator, doesn't that probably mean you're doing some working? So that might be a signal that you may want to show me what buttons you were pressing and why you were pressing them, right? Because I'm assuming there's some formula involved that you used.
Is it an open book test?
Right, let's move on to that. You are allowed to use anything that is written down. So in that sense, yes. So if you've got good notes, you know, like maybe you've printed out a couple of those PDFs that I put online, you know, with what a cluster sample is and all that stuff, right? Like that, you can use them. I would strongly suggest that you write some of those formulas that we did today, but shouldn't you also do the mean plus or minus 3 standard deviations and the one to do with interquartile range? Do you know those kind of formulas that you use to answer questions? Write anything that you think is going to help you, right? So that is a plus. Textbook, if you've got one, you can use it. When you go to WebAssign, everything will disappear except test 1. So you won't be able to go in and look at past homeworks because they won't be visible. But you can look at their ebook. So if you don't have a textbook, you can look at their ebook. I wouldn't spend a lot of time doing that. If you have to spend 10 minutes on each question, just looking up how to do it, well, it tells me you don't know how to do it for starters, but you'll run out of time. Right? You just won't have enough time to do a test. So try and have as much in your head as you can. That just makes your life so much quicker. Does that answer your question, Isabel?
Yes, thank you.
Okay. Calculator is allowed if you've got a TI-84. Helpful thing to have, right? What else? I think that's that part done. Any other questions so far? Anything come to mind? Yes.
So on Wednesdays I have English on campus beforehand. So I will be on campus for Wednesday and I have to wear a mask. Is that
That's
okay?
okay. I'll know it's you,
Okay.
unless you've got a twin sister,
Okay.
right? And that wouldn't bother me. I'm sure you'll be fine. Although if you suddenly got 4 inches taller and your hair went black, I might be suspicious. It's a joke. Okay. Are you looking now still at test 1? Math 146. Okay. You've done your working, right, on that piece of paper for the questions that you needed to do. You might be wondering, well, how does he know? I mean, you don't hold it up to the screen because I can't read that small. What you do is you're going to have to turn that written work into a PDF. So that's where we're coming to next. I'm going to stop this sharing for a second because there's something I need to do. Here we go. Right, now I'm ready. We are going to use you can use a program called Microsoft Lens. Some of you might be using Adobe Scan. Some of you might use an app called Cam Scanner. You might have an app I don't even know the name of. I don't really mind what the app is. You're going to take a picture and convert it into a PDF. So the one I'm giving you, if you want to use it, is that. In fact, some of you have a printer and you just scan it, right? But whatever way you do it, it's probably going to be 1 page. If you write small, it definitely will be 1 page. So you don't expect a lot of pictures. This is the guy, Microsoft Lens. If you've got an Android device or an Android tablet, that's the link. Download the free app called Microsoft Lens. Good company, so you don't need to worry about, being hacked or anything, right? It's pretty sure Microsoft's pretty honest that way. Or an Apple, because you might have an Apple phone or an Apple device. And I'll give you a very, very quick rundown. Here is a big long video that tells you how to use it. And I'll jump to here, Office Lens. I'll jump a bit further, and I think it's about here. And it is. So let's pause and play. Okay, it should be talking, but evidently I hit the wrong button when I went inside share sound. It basically, this video shows you how to use the program. Right, that's what it's there for. So it didn't work quite as well as I wanted. I'll give you a very, very basic description of how it works. This is how it would work for me. Where's my phone? Okay. Let's suppose I do some calculations. That's my working for a question, right? Swipe this guy. You see my little app, Microsoft Lens? Hit it. Give it a few seconds to do its thing. Now, don't know how much you can see, but can you see that if I move it up high enough, I may have to stand up for this. There we go. Come on. Yay. I can even move it up and down a little bit to make sure I got all my paper. Now, there's my guy. You see it? One page probably. Hit confirm. Looks good. Yeah, looks pretty good. Hit done. And it tells me where I can send it. If you've got a OneDrive, do a lot of you have a OneDrive account? You could click on OneDrive and anywhere else you'd like to save it. I want to save it as a PDF. You notice I've put a little PDF check on it as well. And then just hit save. That's it. There's some examples of it. If I click on this one. Eventually, my phone wants to behave. No, I don't want to do that. But can you trust me that it works? Take a picture, turn it into PDF. So let's, oh, we get some charts. There's things I need to ask. Okay. So let's return now to, you've taken your picture of your working. It's a PDF and you want to get it to me, right? You're trying to figure out, how do you get it to me? Do you see this guy here? That's the one you click. So you click on this, you then go, oh, my apologies. That's what I see. Okay, now you click on that. This is what you will see. So you go start assignment. If you put it in OneDrive, you click on that, and then you can just choose your, your test. I'm going to do file upload. So get it onto your desktop or wherever you put it. Call it something easy to remember, like Math 1, 2, 3, John Smith, test 1, something like that. And then open. And finally, submit. And if you do it right, here it is. Now you can practice doing that until you feel comfortable that you know how to do it. And it doesn't matter if you have loaded up a picture of your kid or 42 because you wanted to do a practice. When it comes to the day of the test, just hit new attempt, choose file, pick the one you really wanted, which is your test, hit open again, and submit again, right? Just do it again and again till you're happy. And whatever the old one is now gone, and I got the new one. Do you feel comfortable about using that guy? If you've used Adobe Scan or Cam Scanner, they're not an awful lot of difference, right? They're pretty intuitive usage. Any questions so far? Are things going okay, or have I just told you too much? Okay, all right. You know that this video gets recorded, so you can always go and watch it again if you forgot something I may have said and you weren't 100% sure maybe what I said as well. So let's leave the student view. And I think what we should talk about now is what is in your test. Okay. You are not going to get a question on using SALT. You are going to get questions from all of these sections. So 1, 2, 3, 4, 5, 6, 7, 8. So you're talking 8 questions. Now, some of these questions will be quite short. You know, the kind of ones where they tell you a story and say, what kind of sample is it? Here are 5 choices, pick the dot. Right. That's what some of your sections are going to be. Others will be quite big. Can you imagine that you might have a lot of questions, you know, an ABC kind of thing going on with the regression stuff, for instance. Or maybe conservative margin of error or something, right? You might have a little bit more work to do in those ones. Not all questions are worth the same. Do you know if you get a question and there's 4 answers and you have to pick one, would you agree that's probably not going to be worth the same as a question where there was an A, B, C and you had to do all sorts of things to get the answer? So it's not every question, but it will add up to 100%. So it will add up to 100 points. And it will be chronological. So the first question you will see will be from types of variables. So can you imagine it might be giving you a list of a variable and ask you, is it categorical or is it quantitative? Is it continuous? Is it ordinal? You know, all those kinds of things. And the last question you'll get is from the sampling methods. I might give you a story and ask you what kind of sample it is. Or I might say, what's wrong with this way of sampling? What kind of bias would it cause? You know, those kind of questions. But those do tend to be A, B, C, or D, right? 4 choices and you pick the right sentence that makes most sense. Are we good?
Oh, I have a question.
Yes.
So I have the TI-84 app on my phone. Would I be able to use that?
You won't like the answer, but no. Now I have to kind of
Okay.
tell you why I'm not going to allow you to answer it, use it. I don't know if you're using that or you're doing an internet search to find out the answer to a question.
That makes sense.
Sorry about that. You can get a hold of a TI-84 as a loaner. Any old calculator will do, because can't you use SALT to do, you know, standard deviation and means and things like that? So you probably won't need anything too sophisticated. So you should be able to get around it. Or just beat up one of your relatives and steal their TI-84 for a day.
Okay.
You're not allowed to beat up relatives just because I said that. You know that I'm joshing. Eric, you will not beat up anybody to get a calculator, correct?
I have a TI-84.
Okay, so you, well, there you go, Moran, go over to where Eric is, beat him up and steal his. Yeah, we've cured that problem.
Sounds like a good idea.
Okay.
Being a combat vet, probably not a good choice.
Okay, what else have we got? That was a sensible question, actually. I can't think of anything else, but that's me. I think I've covered all the obvious stuff. If anybody comes up with a question, because maybe you don't know what you don't know until later, if you shoot me an email, I'll try and reply to it. And if it's a really good question that I should have told everybody, on that place where I put all the other stuff, I'll probably have one more tag if I find out that I got a good question. Useful things to know, right? Or frequently asked questions or some heading like that. Right, Anne Sherelle, what you got for me?
I didn't quite get the time for the test Zoom meeting.
The test starts at 1 and it will probably finish around about 2:30 to 3, somewhere in that region.
Yeah, thank you.
You shouldn't need more than an hour to do the test, so you'll probably be finished, I would hope, long before then. Things are going nice and quiet. Any more questions? Right, so did I mention that I'm changing the time that the homework is going to be due from Sunday midnight? Did I mention that? Right. One of my other students went and said, and it made sense to me, that since Monday's a holiday and you're not, and that particular student didn't do the test till Tuesday. In your case, since Monday's a holiday and I won't see you until Wednesday, that we'll move the due date to midnight Tuesday. So you've got until midnight Tuesday to get your homework done. So that might make it a little bit more flexible for you. But the negative side of that is there will be no extensions granted. At the end of this 3 weeks, it's a hard cut. Whatever you've learned, whatever you've done, that's it. Boom. So don't ask me for it, you're not getting one. Right, you're just going to get the test on Wednesday and that's cool. And when you come back on your case Friday, you start a whole new sequence of 3 weeks from scratch. So it's like resetting the clock. I think I haven't mentioned it yet. Do you know one of the 3 tests gets kicked out? I only keep the 2 best. Not that that's a thing, but won't it make your stress level go down a little bit when you know it's, you know, if you screw this one up, you still get, you know, I'll throw it away, right? And you'll still keep the 2 good ones after that. But I'll be honest with you, this is going to be the easiest of the 3. So try and do your best on this one so you keep a good one, right? And you can throw out one of the other 2 when they come.